Questions on any of the homework assignments before we get started? So the first thing we have is this here. Because logarithms and exponentials are inverses of each other, they undo each other. Log base b of b to the x. If the base of the logarithm and the base of the number inside the log are the same, they're going to simplify out and leave us with whatever the exponent is. So if the exponent's 1, it's just going to be 1. Here it's x, so it's going to be x. The same thing is true the other way around. If we put a log to the base, the same base as the base of the log, they're going to cancel out and leave us with what's inside the logarithm. That's interesting. So, if we look at this first one here, 10 to the log of 4. 10 to the log of 4. Well, the base of the logarithm is understood to be what for this one here? 10, because it's not written. When we have log and the base not written, that base is understood to be 10, telling us that we have 10 to the log base 10 of 4. Since the base and the base of the logarithm are the same, they will simplify out, leaving us with what? Yeah. It has to be in an exponent. Because since the base of the log is 10, and the base that we put the logarithm to is 10, they simplify out, leaving us with what's inside the logarithm, which is just 4. Log base 5 of 25 to the x. Now, if this was, say, 5, log base 5 of 5 to a power, that log base 5 and the 5 inside the log would simplify out, leaving us with the exponent. But unfortunately, it started out with 25, not 5. But that's fine, because 25 can be written as what? 5 squared. And by doing this, we can now simplify that log base 5 of 5. But before we do, we need to simplify what's inside that log, because our 5 squared to the x, powers of powers multiply. So our second to the x is going to be 5 to the 2x. Now these two match, so log base 5 of 5 to the 2x will reduce to 2x. Questions on either one of these here? We ready for the next one? Ten to the log of 18 would be because the log and its base are the same. As long as they're the same, it simplifies like this here. Now, unfortunately, log base 4 of 16 to the x won't just simplify as it is, because for it to simplify, we need what's inside here to be also to the base of 4. But 16 can be written as what? 4 squared. Which tells me I have log base 4 of 4 to the 2x, because powers of powers multiply. And log base 4 of 4 to the 2x would indeed simplify to 2x. Questions on either one of these here? Questions on anything we've done so far? We're ready for the next 4. 8 to the log base 8 of x. Yes, it would be x. Log base 7 of 7 to the negative 3x. Yes. Almost. Because for this to simplify and this to reduce, we need the base and what's inside the log to be the same. So for this to reduce, since the base of the log is 2, we need what's inside to also be 2. So it's figuring out 2 to what power is 64. And it does work out that 2 to the 6th is 64. Telling us that log base 2 of 64 to the x is the same as log base 2 of 2 to the 6x, which would simplify, leaving us with 2x. And the last one is indeed 20. Because for natural logs, the base is understood to be e, so we have e to the natural log base e of 20. They match up, leaving us with 20. Questions on this here? Be ready for the next one. Now, as I said, logarithms and exponentials are inverses of each other. So we were going to find the inverse of each one of these here. Now, the first step in finding the inverse is to rewrite f of x as y. Now, if the function does not have f of x to start with, we're going to skip step 1. We're only going to do this step if it gives us f of x to begin with, if it starts it off in function notation. And for a, it does. So we're going to rewrite f of x as y. Step number 2. Switch x and y. Because a function is going to take a input, a value of x, and map it to a value of y. It's going to take a value of x and connect it to its corresponding value of y, its output. An inverse function is going to take that y value and connect it and map it back to the x that it started with. It's undoing it. It's going back. It's switching the domain and range. So here, y is going to become x. We're still going to have the equals to. We're still going to have the 6, but instead of to the y x powers now to the y. We need to solve for y. We need to get y by itself. And to do that, we're going to have to turn it into a logarithm. To get that y out of the exponent, we're going to have to switch it to a logarithm. And based off of what we were doing the other day, switching it to log, we would have log because the base is not e. And what would the base of this log be? It'd be 6 of x is equal to y. Because log base b of x equals y if and only if b to the y is equal to x, or b to the y equals x if and only if log base b of x equals y. We're just switching from one to the other. And lastly, rewrite y as f inverse of x. That -1 between the f and our parentheses signifies that this is its inverse. So f to the -1 of x is f inverse of x. We're saying that this is the inverse of our original function. And we only do that if it started out in function notation. So if it starts out in f of x, we need it in function notation at the end, so we're going to have to use f inverse. If it does not start in function notation, it will not end in function notation. We only need it if it is given to us in the original function. Questions on this here? Let's look at the next one. Y is equal to the natural log of x plus 3. Well, since it's not written as f of x, it's not written in function notation, we don't even need step 1. It's already done for us. Step 2 is to switch x and y. So we'll have x is equal to the natural log of y plus 3. Now, the only real way or good way to get the y out of the log is to rewrite it as an exponential. So we would have e to what power? It'd be e to the equals y plus 3. Because our switching that we did the other day still holds true. It still works, even if what's inside the log is more than one term. Is y by itself. Now, so what do we need to do? We need to solve for y by subtracting 3 from both sides. 3 minus 3 will simplify out, leaving y by itself. And that's going to be equal to e to the x minus 3. Questions on this here? Okay. We're ready for the next two. F of x equals 11 to the x. Well, the first thing we're going to have to do is replace f of x with y. So we get y equals 11 to the x. Next step is to switch the x and y. I'm going to do something interesting, because this is another way to do what we've been doing. but might help you keep some of the terms straight. If I apply log base 11 to the right-hand side, we get this here. Log base 11 of 11 to the y. What would that become? It would become y, because the base and the base inside, the number inside, are the same. So we're just left with y, yes? Yeah, because that's what we just did earlier in here. But what I do to one side, I have to do to the other. So I also have to apply log base 11 to the left-hand side. But it doesn't simplify. It is still just what? Log base 11 of, well, we did just this. We did do the switch. So this is what we've really been doing. We've been applying log base 11 to both sides. Because log base 11 of 11 to the y simplifies the y. Log base 11 of x is just log base 11 of x. Equals log base 11 of, and that's it. Questions on this here? Now, for the most part, we're going to end up using this method from the rest of the year, because this is a little bit nicer. We're not having to keep straight what x, y, and b are taking the place of in the equation and then switching it. It does work very nicely. Are you ready for the next one? Y is equal to the natural log of x plus 6. We don't have to rewrite it as, we don't have to rewrite f of x as y because we do not have an f of x. So we can just go on and switch x and y. Now we can do a similar thing to what we just did on the last one, but this time we're not going to apply a log to both sides because we already have a log. So what we need is an exponential, because exponentials and logarithms simplify each other out. And to do that, we need to put both sides to a base. And that base is going to match whatever the base of the natural log or the log is. What is the base of this log? E.
Have your attention. If anyone has found a car key, please bring it to the office at this time. Thank you.
Now, e to the natural log of y plus 6, the e and the natural log will simplify each other out, leaving us with what? And the left-hand side becomes? Yeah, we can switch the sides. Questions on this here? Questions on anything we've done so far? We're ready for the next one. Y equals 4 to the x. I'll rewrite it, you don't have to. We are not in function notation, so the first thing we can do is switch the x and exponent. Now we need to get that y out of the exponent. The only way we can do it is with logs. Now I'm going to apply a log to both sides, but I need a specific base. We can't just use 10. In this case anyways. What would the base of this log need to be? 4. Because for this to simplify on the right-hand side, for log base 4 of 4, we have log base 4 of 4, is going to simplify to y. We need that base, and the base inside the log to be the same. Huh? Both work. then do the other one. And on the left-hand side, we get and since we didn't start off an exponential, this is all we have. The switching method works great. The only time we have to be careful is with inequalities to make sure we don't flip the inequality. Because equations, it doesn't matter. Log base 4 of x equals y equals log base 4 of x. If we said log base 4 of x is greater than y is not greater than log base 4 of x. We can't just flip those. We have to keep the inequality signs pointing towards the correct one. So we got to be careful with those. But here, works just fine. Y equals the natural log of x minus 5. No function notation, so we don't have to rewrite f of x as y. So the first thing we can do is switch. X and y. Then what do we need to do? Rewrite it as an exponential. So yes, we can put both sides to the base of e, and we would indeed get e to the x is equal to y minus 5. Now, since y is not by itself, we need to solve it, and we can do that by adding 5 to both sides. Telling me y is equal to e to the x plus 5. Questions on either one of these here? We're ready for the next part. That's it.